Welcome back. We're going to look at the chain rule now and figure out, at least heuristically, why this rule is the way it is. We're going to play a little bit fast and loose, make some assumptions. These all can be done rigorously, but we're not going to do that here. All right, so here we go. So remember, the chain rule said this. That for differentiable functions, the derivative of f composed with g was just f prime, then evaluated at the inside, times the derivative of the inside. So let's check why this works. The start of this problem is just as you'd think, d by dx of f of g of x is the limit as h goes to 0, where you plug in x plus h, so f of g of x plus h minus f of g of x, all divided by h, and let h go to 0. All right, this result isn't obvious if you're just staring at it in this form, so there's a trick, and the trick is to multiply by 1 in a clever way. So here we go. I'm going to keep the numerator here, f of g of x plus h minus f of g of x. And I'm going to multiply that, and then I'm going to put the h over here. And I'm going to put g of x plus h minus g of x here, and g of x plus h minus g of x here. And since those are the same things, they would cancel, so I haven't changed anything. Though technically this is only legal as long as that numerator is non-zero. As I said, there are ways around it in general, but let's pretend for now that it's non-zero, so that's a legal thing to do. All right, now let's do the limit of a product as the product of the limits, at least when they exist. So here, we'll put limit as h goes to 0, g of x plus h minus g of x all over h. Okay, and that's good news because we see right away this is just going to g prime of x. So that's the definition of the derivative of g. So it's just this first part here that we have to figure out how to handle. And the trick for this is to, essentially make a substitution. And here it is. You let k be this bottom part, g of x plus h minus g of x. Alternately, you can write it this way, that g of x plus h is the same as g of x plus k. And because g is differentiable, it will be continuous, so as h goes to 0, g of x plus h will converge to g of x, so that the difference of those two numbers, k, will also go to 0. Okay, so coming back down here, we can write this as the limit. Instead of h going to 0, we can say k is going to 0. And the g of x plus h, that's just g of x plus k minus f of g of x all over, now just k. And then we also had g prime of x tagging along. All right, this is just the derivative of f, except evaluated at g of x. Okay, so we get f prime at g of x times g prime of x, which is the end of the chain rule. See ya.